Nice talk, thanks. For some context for my question, will you go back to one of the slides that mentioned Claude early on, maybe about your 7th, 8th slide somewhere there? Yeah. Right, perfect, that one. So you sort of talked about a thing drawn on a whiteboard or a piece of paper, and then you've got this cycle. This was the only place in your talk where I could detect anything about checking the results of what it is, and it says check consistency there. I'm really curious about if you could say a bit more about what check the consistency of what, and how does the human who's driving it express requirements, and what can get checked, that kind of thing.
Yeah, so I mean, there are various checks. So this is consistency is one of them. It's just whether the workflow is actually constructed correctly, right? So do you have the other jobs in the workflow, the ones that you expect to be like you had it imagined? So do they match the intent that you had? Do you have all the files that you indicated, are they all present in the workflow? So these are simple checks of whether the high-level intent that you have actually matches what the system has produced. Now, there are also other tests that now you have. This is just on paper, in some sense. The workflow looks like you thought it would look. But then, even if you have a perfect mirror of what your intent was, you still have to test and make sure that what you imagined in your head actually is scientifically meaningful. And this is the test that you're doing at small scale and validating it. So this is a typical test that you do anyway, even without AI tools. But then when you're using AI to help you compose the workflow, you have more of a challenge to actually figure out that what's going on is correct.
Yes.
Yeah, thanks.
That's it.
Thanks, I really enjoyed that. I'm reminded of Andrew's talk last year where big platforms equals big problems. So it's quite nice to see some big problems that we don't have here in New Zealand. I guess I was interested in the sort of the multi-agent across multiple different platforms. How much do your agents actually need to know about sort of the details of how each of those platforms are operating to get to kind of a good cost function for placing jobs? And what's the kind of the ongoing development you think you're going to need as these platforms all run off in different directions? Or do you think that's not a big issue?
Yeah, so this is really, that part of the work is really in the research realm. So right now we assume that the agents know what the capabilities of the other agents are. So you know that you're talking to an edge agent or you're talking to an HPC agent, right? So, but what I imagine is actually you'll be able to deduce that based on the consensus algorithm. So you can send additional information across the agents, not only which jobs you want to select, but also additional information about what's going on with your system and so forth. So I do see that as a progression. And altogether, I think ultimately the solutions to these distributed versus centralized is something in the middle. I don't think everything will be totally distributed. I don't think the centralized type of approach is appropriate. So I think it will be somewhere in the middle in terms of organizing the agents in different ways. So right now we're looking at, we had basically a flat topology of agents. We're also looking at hierarchy, where you introduce new additional challenges of leader selection, but again, we can use distributed system concepts to do that, but that's another level of exploration that you can do. What's nice about, and interesting about the agentic frameworks is this ability to learn over time, and that's really the key. So you can then marry the distributed systems algorithms that have been proven for many, many years to work well with additional knowledge and capabilities that agents learn over time so that you have fresh information and fresh view of the world. I don't know if it totally answers the question. Okay.
Ben.
I just had a question about your user interface. I mean, you've got your DAG up here on a whiteboard.
Yeah.
I saw some text-based output. So I guess what is your user interface going from this DAG over to this implementation look like? Is it more text-based, script-based? What does that look like?
So that's something that we're having intense discussions in my group because right now there's a lot of different ways of entering. I actually gave ChatGPT a sketch of a researcher from France who's doing research in helioseismology, and we worked with them also for, 15 years. And I picked up that napkin drawing from him, and I gave it to ChatGPT, and it did create the correct skeleton for that workflow. I then told it, okay, this is helioseismology. What kind of data sets do you have? So that's a way of developing a workflow. Another way is to use Claude. And I think from ChatGPT, to actually get things working, you might have to go to Claude Code. That's been the best way of creating runnable code, let's say. So you use Claude, you can give it, we have in our GitHub, we have a number of different workflows that have been vetted over the years. You just give some example workflows to Claude and say, this is kind of a structure. You can create your initial workflow with that. What's nice about Claude, you can also say, okay, now I want to add this node, I want to add another computation. So that's a way of generating the workflow. Now, if you are a good coder, you can just use the Pegasus Python API and just do that. But if you're a scientist that's trying to figure out maybe what they're doing, or don't want to learn too much about Pegasus, just want a workflow that then just gives it to a compiler to run, then I think this Python Claude interface might be good. It can be integrated into the Jupyter framework that people use, and I think that that might be a good way to go. So yeah, it's hard. So it depends who you are. Then it depends how you actually create these workflows.
Anna.
So this was not my question, but just to build on what Ben was saying. This is Anna Gainaro from Oak Ridge National Lab. So we work a lot with workflows as well. And a big issue is the fact that each little piece requires different packages, and when you run them together, then you have conflicting packages, and it's such a pain to build them. So just by giving it, this is what I want you to run, build me the workflow, it's not going to be enough, right? Because you will have to be able to run them together. So
so you can use containers. I mean,
this is just another layer.
So containers are often what people use to be able to isolate things. And
assuming that you ran this workflow in this configuration before, right?
Well, so oftentimes, scientists have codes that are already used for the work. They want to put them together, right? So that's oftentimes what we see is they have some kind of code that they're running. Now they want to run something more complex. They want to add additional steps to it. So they build up this workflow, but they have the components.
Correct, but the more freedom we give them, like just talk to an agent and they will build your, this problem is going to come up. But that was not my question. My question was on provenance. You were saying you're saving provenance. When you keep adding agents into your workflow, what kind of provenance do you save from that? Do you save the reasoning that they use to come up with an outcome, their actions and all this, so that you can learn in the future if something went wrong?
No, so we don't do that currently. The provenance tracking is at the workflow execution level. So we're looking at the science part, keeping track of the science part, not the composition part. But that could be added as well. Mm-hmm.
Have you done any measurement of how much processing power or network bandwidth this workflow has used or will use?
So in terms of the executable when it's running?
Correct.
Or what the Claude and others are doing?
Well, I mean, I suppose it will grow in terms of usage, but whatever you've accomplished so far, and of course when you implement more of the AI into it, then I think the usage will go up.
Yeah, so we're not tracking that at this point. We're looking at developing the methodologies and exploring how far we can push this and see what are the benefits of this type of approach. So we're not tracking that right now.
Ilkay.
But good thing to do. Okay.
Great talk, Ewa, as usual. I love that this coordinates the computational activity, which is the main goal of the workflow here.
Mm-hmm.
How would it connect to agents that bring more intel about the data in the back end from across those systems? And would there be some compatibility between data agents and workflows coordinating it?
So, I mean, today is the agents or the different LLMs can bring you options of what data to use for your problem. So I mentioned the helioseismology workflow. I can, once you start talking about, it's a helioseismology, I want to look at a particular type of behavior of sun properties and stuff, it can start giving you ideas of what kind of data sets are out there and what you can use. And I'm not a helioseismologist, so maybe not complete, but it certainly gives you various options. Now, it's really the onus is on the user. Now, it basically shifts, as I mentioned, from the creation of a product to the validation, because as a user, as a scientist, you need to decide which data sets are appropriate for you and which computing is appropriate for you. And I think that part is still okay. I think the challenge is if you start using these things in education, and then you're dealing with students that are trying to understand helioseismology, for example. How would they know which data sets are appropriate? So they need guidance to be able to use, to decide which data sets are appropriate for the work, to use critical thinking in terms of analyzing is the type of codes that I'm putting into the workflow something that is useful, and then have a result something that is as expected. And this is a big challenge, right? So determining whether what you're getting at the end, because you'll get something, but what you're getting at the end is appropriate.
Eric, and then Amal.
Excuse me. I find the agentic side of things quite compelling, particularly because in heterogeneous environments like lab as well as HPC, it can add quite a lot of advantage. The thing that I was wondering is it model agnostic, and can you choose which AI model you run for each particular agent or for perhaps the entire system? And whether there's any consideration on that regard to privacy, sovereignty, and that sort of stuff with regards to the data.
Yeah, so in this vision, it has to be, you have to be able to mix and match models, because you have agents that are running on a small edge device, and you have agents that can be running in an HPC system. They have different types of capabilities. So you need to be able to mix and match. I think, the thing that I haven't talked about, and I'm sure is on people's mind as well, are issues of security in this type of environment. So I think that's another issue that comes, especially when you have different models coming together. You need to be able to have some assurance that either the agents are behaving as expected, or you use, again, some distributed systems algorithms to be able to figure out, come to partial consensus across some agents, detect which ones are not behaving well. And I also heard some program managers from some agency, not to be named, looking at issues of, basically figuring out which agent is a malicious agent, and then capturing them and turning them into the agent that works for you. So, you can do various types of maybe putting in a different model for that agent to use, but yet still behaving in a certain way. So lots of interesting work in that space.
Thanks for the presentation. So you mentioned that in future work you want to integrate that with autonomous labs, and I guess in there it's going to be I guess, more problematic to use these agents in the sense that you cannot necessarily trust them in their decisions. So like when you're dealing with computational workflows, at worst, it's going to be some node hours that you're going to lose. But if you deal with autonomous labs, then probably the lab is going to explode if some wrong decision is going to be made by these agents. So is there some work that is happening or being done or thought about on the reliability aspects when it comes to physical systems, or that's still in future work?
Yeah, so it's future work, but people are thinking about it. Really thinking, especially if you're looking at the beamline, for example, that you don't want it to, and you try to tune the beamline, you probably don't want to, burn a hole somewhere or explode something. So there is always, right now the approach is to have a human in the loop and make sure that what's happening is appropriate. You can also, I know there is research where people are looking at putting in guardrails to make sure that the agents, the results are within a particular norm of what you're expecting. There are also aspects of malicious agents, but in a self-driving lab setting, you might isolate the agents in some fashion so they don't have additional external influences.
So great talk as usual, Eva.
Thank you.
This is related to the question that was just asked. We're used to workflows being quite deterministic in how they execute. Right, and that's how we build it. You're adding multiple levels of uncertainty as you move towards your, the progression that you described. How do you communicate that to the user?
That's an interesting question. I don't think I have a good answer, except that when we're moving towards these novel technologies, you have to involve the users, or at least the operators of the infrastructures, of the instruments, and very closely in your decision making and in what you're trying to do. And I think that's really the collaborative mode between the people that run the instrumental facilities and the cyber infrastructure workflow AI folks have to just work very closely together to understand what's needed, like putting the appropriate guardrails, putting various checks like that, which is an important element of being able to safely put in technologies. But the other thing is the instrument facility people need to also, and they understand the promise of AI and automation and things like robotics, for example, for doing sample swapping and other things and making decisions looking at samples. Is this a good sample or not? So there's a lot of opportunity that the research facilities leaders see in the AI. So really working together on this is the only way to move forward. You cannot just throw things. So here are your agents. I'm going to deploy them tomorrow, and we'll see if it blows up or not. Yeah.
So please join me saying thank you to Ewa. I mean.